Greetings, Saintsmen. We are on lesson 5.4, equilateral and isosceles triangles. If you remember, when we started discussing these things with regard to equilateral and isosceles triangles, the definition we gave for an isosceles triangle was that there were at least two sides that were congruent. So something that I want to share with you here in this theorem that we're going to apply also, obviously, since an equilateral has at least two, right, that qualifies under that definition, has three sets of congruent sides. This is also going to apply to that. So we have these two legs that are congruent in this case of this particular isosceles triangle. Let's name some parts of this. For example, these congruent parts are what are called the legs of that triangle. And then moreover, we have the base, which is the non-congruent portion. These guys right here are what are referred to as base angles. And there's also one more part that we're going to not use this very often, but that in between the two legs, that included angle is what's going to be called the vertex angle. But again, that term we're not going to discuss very much. The base angles we are, because what we have here in the case of isosceles triangles, right, is that if the two sides of a triangle are congruent, then the angles opposite them are congruent. In this case, these base angles, which are opposite, right? So if you're from the side, there's only one, or at that leg, there's only one side that's going to be, or one angle that's going to be opposite, and that guy has to be congruent, okay? Conversely, it's also true. If the angles are congruent, then the sides opposite will be congruent, okay? So, there we go. Let's go ahead and do an example. So here we go. We have our triangle here. This guy is going to be named A, B, C. Okay. If angle A is congruent to angle B, we're going to name two congruent sides. Uh-oh. Sorry, guys. A little crash there. Let's go ahead and get this guy fired back up. Okay, so the way that this is going to work, of course, I'm going to do this guy in blue. So we have our congruent angles. It's going to be this side that's opposite, right, which is AC, and this side from A that's opposite, which is BC. These are going to be our two congruent sides. So that is your answer. That's it. Okay, let's do another problem. So we have a triangle, and it's isosceles, so at least two of the sides are congruent. We have one angle here, which is 2x degrees, and we're going to find the value of x. Now, what should we know here? Well, all the sides opposite these congruent angles are going to be congruent. In other words, this angle is going to be congruent to this angle, which is going to be congruent to this angle. Now, the sum of all of those is going to be 180 degrees. Now, think about this. If this guy right here is 2x, then this guy also has to be 2x, and this guy also has to be 2x, right? So the sum of those three, 2x plus 2x plus 2x, is going to be 180. All right? Take our sum. It's going to be 6x, which is equal to 180, and we divide by 6, and we're going to get that x is equal to 30. Pretty straightforward. So just utilizing our previous theorem, such that the sum of the interior angles of a triangle are, of course, 180 degrees. Okay, continuing on. Let's get a new triangle. Okay, we should care, again, how it's marked, not how we see it. So while this doesn't look like it's equiangular, it's marked that way, okay? So the portions we have here, this guy is going to be 2x degrees. This guy is going to be 28. This guy is going to be 28. And this side is going to be 4y. Okay? And we are going to find the values of x and y. Before we continue on, I'm sorry, I'm managing something in the live meeting that's going on right now. All right, so how do we do this? It doesn't matter which one we do first, but think about this. If all of these sides are equiangular, it means that this is going to be congruent to this, it's going to be congruent to this. Okay? So if this guy is 28, it means that this side also is 28, right? And the reason why is because this guy is 28. Okay, so what it means is that this side of this triangle is going to be congruent, meaning that the angles opposite here and here are going to be congruent. All right? So it's important to note here. So, which one do we want to do first? Well, I think there's one that should be pretty clear, which since this and this are congruent because they're marked that way, we can do a quick little 4y equal to 28, right? To solve for y and to get that y is going to be equal to 7. What we're not given is this side over here, and that's okay. We may not need it, right? But really thinking critically about this, how are we going to solve for x in this case? Again, we know that 2x is also going to be this angle over here, okay? And trying to figure out from 180, is it possible for us to solve that, right? So all those sides are congruent, okay? Now, if all of these angles are congruent, it means this is equiangular, meaning that this is going to be 60 degrees, 60 degrees, and 60 degrees. How did we get that? Well, if they're all equiangular, remember, the triangle sum has to be 180. So in other words, x plus, and by the way, we don't necessarily need to call that x. We can call this guy just question mark, right? Question mark plus question mark plus question mark is equal to 180, right? So 3 times that, if we were to take the sum of that, it's going to be 180. So of course we're going to get, that is going to be 60 again. If all the angles in a triangle are equal, all the angles in whatever polygon, you just take the number of angles and you're going to divide by whatever the interior angle sum is, right? So it's 180, so we divide by 3 to get 60. Now if this is the case, think about the relationship of these two angles. These are a linear pair, correct? So if that is the case, then that angle right here has to be 120 degrees. Has to be, has to be. So what we can do to solve is that we're going to have 2x plus 120 is going to be equal to 180 because that's going to be the interior angle sum of our other triangle, okay? So 2x and 2x is 4x And now we're on our way algebraically. I'm going to subtract 120 from both sides. 4x is equal to 60. We're going to divide by 4 on both sides, right? And we're going to get that x is equal to 15. So we have to use knowledge that we have of triangles, right? Of their interior angle sums, linear pairs, all these things are in play for us to be able to solve these problems, okay? We have one more example for today. So it's this. We're going to do one more of these. And we're going to do a proof. Okay, so here's our triangle. Which is P, Q, R, S, and T. So what we're given here is that PT is congruent to ST. Moreover, that PQ is congruent to SR. And what we are going to prove is that we have triangle PQT, and it is going to be congruent to triangle SRT. Okay? So it's going to be a little bit more challenging than what we've dealt with before. I think as we start, what's important is that we need to mark our triangles, okay? Or mark our diagram. So we know that PT and ST are congruent. We also know that PQ, right, and SR are congruent, okay? Now, a few things as we move forward. Okay, so let's go ahead and do our given. And what we're trying to do, it's PQT. It's this triangle right here. Okay, and this should be actually like kind of a one-step, or it's going to be a three-step proof. Because after our given, right, which is PT congruent to ST, and PQ congruent to SR, we need to show one more set of things is true, and it's this, right? Again, we're trying to show this little triangle and this little triangle as being congruent. Now, things that we can deduce. Think about this. Do we have an isosceles triangle? Look at the larger triangle that we have here, this guy, okay? We have PT and ST being congruent. What that means is that this angle P and this angle S have to be congruent, right? And the reason why is that these are base angles. It's the base angles theorem for the isosceles triangle, right? Those base angles that are opposite, right? So imagine that we, again, don't have, right, QT and RT. You guys can see that that guy's clearly an isosceles triangle, right? On that bigger triangle. So we're pretty much home free, because right here, this angle is included. It's sandwiched between PT and PQ. So we have a sufficient amount of information to say that PQT is congruent to SRT. And the reason we can do that, of course, is our side angle side congruence postulate, which we have the included angle P and S. All right. So, question, is this triangle right here, QRT, just a little side thing? Just wondering about this guy. Is QRT an isosceles triangle. All right, and let's consider this guy QRT, right? What we should know is the following. We can also deduce that QT is going to be congruent to RT, right? And the reason QT and RT are congruent is because these are corresponding parts. In our congruent triangles, right? QT, second and third, RT, second and third, after we've already proven those triangles to be congruent. So now that we've actually proven those two outside isosceles triangles, QT and RT are congruent, which means triangle QRT, by definition, is isosceles, because at least two of the sides are congruent. So, just a little bit of food for thought. Gentlemen, I'm going to go ahead and post your assignment on Canvas right now, and we're going to go ahead and get started. Good luck.